Well, hello there. And today I'm going to be talking about high altitude balloons. I came across this video by Dwayne Kellen. He's launched several balloons, really cool footage, but a lot of them in the past have featured wide angle or fisheye lenses. And so they've come under various criticism from flat earthers saying the curvature is false and all of that. However, this one didn't look like a wide angle lens to me, so let's investigate a little bit further. This is a still from almost the highest altitude the balloon got, 106,000 feet. It went up to about 113,000 in total. And to me, as you watch the balloon, you can go and watch the footage, the links in the description. It's fairly obvious that a wide angle lens wasn't used. You don't see that kind of bobbing and morphing of the horizon that you do as it goes up and down in the frame. And you can see clear curvature on the horizon in this image. Let's dig a little deeper. When I went down into the comments, I understandably saw a fair amount of flat earthers in there. So let's see what they had to say. Christina Graham said 111,000 feet up, no curve. Finally, someone who uses a standard lens, not a GoPro fisheye lens. You just debunked the globe model. And they went on and on. The usual flat water, flat earth proved, the earth will always be flat, no curvature to be seen, etc, etc, etc. And then there was this one, Michael Rutledge, 67, who said, for those people that claim you see a curve, realize we see the same exact amounts of curvature at lower altitudes as we do at higher altitudes. When the camera swings up, we see a convex curve and a concave curve when it swings down. It's called barrel distortion. Look it up. Let's see what sort of barrel distortion we might get if a wide angle lens was used. So this is what barrel distortion does if you weren't aware. Lines that are in the center of the frame like this stay pretty straight. Anything above the center of frame will curve upwards. Anything below the center of frame will curve downwards, following these kind of lines here. It's known as lens distortion or barrel distortion, very common on wide angle lenses like a lot of GoPro lenses. But this is the lens that was used on that camera. It was listed in the on the video description. You can go and look for yourself. It was the 4.35mm no distortion lens. Very clearly states there no distortion. In fact, this is the description on the video, and as you can see, there's the 4.35mm lens that was used in the top view and rocket view cameras. So that states there's no distortion, but we can look at this and do a test. Now this is a still from very early in the video, just after launch. You can see there the altitude is around 170 feet. So we'd expect the horizon to look very flat, and indeed it does. The horizon here is just below the center of frame, and in all the images I've used purposefully used images where the horizon is below the center of frame, because as we saw, even if there was some barrel distortion, that would curve the horizon downwards, not upwards. But this is really a test to see how the horizon looks at a low altitude. You can see it looks flat, but if you do a little trick where you take that still image and just compress it inwards horizontally, like that, what that does is it doesn't distort the image in any way as far as the amount of curve that you would see. All it does is you're bringing the size in, you can see from these flat or straight lines here, hasn't distorted the image in any way apart from shrinking it horizontally. What it does do is it will accentuate any curvature that's visible in the shot. Now we can see here, low altitude, no curvature, very straight line. So far, so good. So here's a shot from higher up, nearly 7,000 feet this time. Again, the horizon just below the center of frame. It looks to me like there's a small amount of curvature there, maybe debatable, but it looks slightly curved. But what we can do is we can use Walter Bisland's excellent and very useful curve calculator tool. What this does is it models the amount of curve that we would expect to see using a mathematical model if the Earth is as science says it is, with the radius that is stated and the curvature that it should have. So we've plugged in the height in meters in this case, and I've also plugged in the width, the field of view, which is 72 degrees for the camera that's in use. And according to the model, this is the amount of curvature we should see at that altitude. And that's how it looks full screen. So you can see a very, very slight curve. And if we overlay that one on the other, you can see that they match up pretty well. That very slight curve that we expect to see is mirrored in what we actually do see. And if we shrink those images horizontally again, then it becomes much more distinct. Here's the curve that we should see if the Earth is as the model says it is, and here's what we actually see. And once again, as you can see, they're very, very close to each other. So let's go higher up. Now we are at 113,000 feet. The horizon's pretty hazy, but it's really obvious now that there is a curve there. Just to make that clearer, I've adjusted the levels, the contrast, the brightness, just to bring out that horizon more clearly. If I flick back and forward, you can see there's nothing else changed with the photo, only the color balance. And now you can really see that there's curvature that you can see there. Again, if we model that out in Walter Bisland's calculator, then we can see that the two things match up absolutely precisely. What we expect to see and what we do see are exactly the same. And once more, now if we pull these in horizontally, both images, we can see that they both match perfectly. And the curvature is absolutely apparent. There's no denying that now. The horizon is below the center of frame. All I've done is shrunk the image left to right. You can do the same thing yourself. Shrunk a little more there, and you can see that the curvature is even more apparent. I don't really know how more clear we can make it. There's curvature that in the model we expect to see, and there's curvature in the image that we see from the balloon of the exact same type. And just to be sure, I took a still from the infrared camera that was also uploaded as a separate video on the same channel. And again, there's the curvature at this same height, 113,000 feet. There's how it should look. And there we go. Compressing the images inwards, you get that exact same curvature to both images. So just for you, Michael Rutledge 67, when you think that you see the exact same amount of curvature at low altitudes as we do at high altitudes, and it's all about barrel distortion, maybe you should look into it first. And as flat earthers love to say, do your own research. Low altitude, medium altitude, high altitude. Distinctly different, and lots of curvature. Thanks everyone for watching. Please like, subscribe, and share, and I'll see you next time.